Today we're going to talk about reaction stoichiometry. Okay, when we talked about the empirical formula and the percent composition, that was composition stoichiometry. We want to know what things were made of. Reaction stoichiometry is the quantitative relationship among substances as they participate in any chemical compounds. Okay, they answer questions like how much product is formed when a given amount of reactant reacts, how much reactant is used to make a certain amount of product. So this would go back to kind of our food example, okay? If I have 3 bags of ramen noodles and 4 cups of water, how many servings or how many things of ramen noodles can I make? 2, because I need 2 cups of water per ramen noodle, okay? So I would only be able to make 2. So that reaction stoichiometry really goes down in the cooking and things like that. It can get a little bit complex, okay? As we work to the end of this, today is relatively simple, okay? Today we're going to talk about the mole ratio. I will tell you, your first step to any stoichiometry problem is to have a balanced chemical equation. If you do not have a balanced chemical equation, you cannot perform a stoichiometry problem. So your mole ratio is you get it from your chemical equation. It's the ratio of coefficients for the 2 substances in the balanced chemical equation. This is the central concept of stoichiometry. Okay, this is the central concept of stoichiometry, and in a way, the central concept of chemistry. The mole ratio is unique to chemistry. Okay, that's why the mole is defined as the amount of the substance. Okay, and the mole ratio allows us to convert from one substance to another. So our mole ratio is always this: is the moles of the unknown substance divided by the moles of the known substance. Where do you get those moles from? Those number of moles. I heard the answer. No. It's in the notes, yeah. No. I need you guys to find a different color. I don't know. So it is from the balanced chemical equation. You get your mole ratio from your balanced chemical equation. So example, I could write a lot of different mole ratios for this, couldn't I? So if I want to find the mole ratio of, what is the mole ratio of P to Cl? The mole ratio of P to Cl. How many moles of P do you have? No. 1. So the mole ratio of P to Cl would be 1 mole P4 divided by, how many moles of Cl do I have? 10. 10 moles Cl. I could say, what about PCl5 to Cl2? PCl5 to Cl2. What's the mole ratio of that? 4 mole PCl5 over 10 mole Cl2. This is not reduced. Okay? This is not reduced. So we know that 4 over 10 we could reduce to 2 over 5. It's not reduced. I could write the mole ratio of P4 to Cl5, couldn't I? From P4 to Cl5. What's the mole ratio of P4 to PCl5? 4 mole PCl5, okay? And then, that had all of them in there. In that case, I could have written 6 of them, okay? I could have written 6 of them. So this is probably a little bit harder than actually applying it, okay? It's probably a little bit harder than actually applying it. So here, this is mole to mole stoichiometry. Here's where we're going. Oh, I'm sorry, people. Here's where we're actually going to start applying this, okay? This is where we're going to actually start applying this. Mole to mole is used to convert from moles of one substance to moles of another substance. We use 2 words. We use 2 things to describe things. We talk about the known, same thing we talk about the mole ratio, okay? The known substance and the unknown substance, okay? The known substance is the substance that you start with, okay? The known substance is the substance that you start with. The unknown is the substance that you're going to. The mole ratio is used to convert from mole to mole. So, once again, we talked last week that the mass to mass slide, I wanted on a whole piece of paper, okay? This is the center of this slide, okay? This is the center of this slide. This is the center of this slide. To get from moles known to moles unknown, we multiply by the mole ratio. So now let's work some examples of this. Given the following equation, how many moles of O2 are produced from 2.85 moles of KClO3? That is the first step you have to do. It has to be balanced. So you do any stoichiometry problem, you must have a balanced chemical equation. A balanced chemical equation. So to balance this one, it would be, somebody tell me? Yes, you're correct. 2, 2, 2, 3. Okay. Balanced chemical equation. Some of your homework's already balanced, some of your homework's not balanced, okay? Some of your homework's balanced, some of your homework is not balanced. A lot. What'd you say, Thomas? No. You can if you want, but you don't have to. I don't explicitly ever ask you to balance it, okay? So, stoichiometry is a conversion problem. So in any conversion problem, what do I do? What's my next step of that? Put what I know over 1. So I know that I have, so my known is KClO3, isn't it? My unknown is O2. So I like to kind of work at this. I know I have 2.85 moles of this. And this is kind of going into, it'll get easier. And I'm looking for question mark moles of O2, aren't I? Is that the question that I'm asking? So back to what Anaya said, I take what I know and I put it over 1. So I have 2.85 moles KClO3. And I put it over 1. Now back to my notes, I'm in the moles known box, okay? I want to go to the moles unknown because I have question mark moles here, okay? So I want to go to the moles unknown. So I need to multiply that by the mole ratio. So still my same steps. Mole KClO3 is going to go on the bottom of this equation. Mole KClO3 is going on the bottom because whatever's on the top of your first step goes on the bottom of your next step. What's my unknown in this question? O2. So moles O2 is going to go on the top. Now, where do I get my numbers for mole O2 and mole KClO3? No. Molar mass was a good, that's tomorrow. The mole ratio. So I get this from my balanced chemical equation. So I have how many moles of KClO3 do I have? 2. I have how many moles of O2? 3. Moles KClO3 cancel, moles KClO3 cancel. And now I need to solve this out. Significant figures do matter. The mole ratio does not factor in this. So in general, how many I start with, how many I need to end with. So I need to do 2.85 times 3 divided by 2. 2.85 times 3 divided by 2. 4. Really? You get 4.275, don't you? I need 3 significant figures, so 4. I would round that to the even number, so 4.28 moles O2. So that's the whole thing. That's today's homework. I'm going to work some more examples of this, okay? This step right here, let me find my mouse. Sorry. This right here is the mole ratio, okay? Same thing we did, so you have 3 for each 3 moles of O2, you have 2 moles of KClO3. I'm getting another one for you. This was maybe, yeah, maybe. All that didn't work out very well. Maybe. Next question. NH3 reacts with O2 to form NO2 and H2O. Oh, you had time to write it down. Yes. Okay, so ammonia reacts with oxygen to form nitrogen dioxide and water. So how many? If 23.7 moles of NH3 would be able to produce how many moles of water? So I know that I have 23.7 moles of NH3. That's my known, and moles of H2 is unknown. So the first step in any stoichiometry problem is to do what? Balance it. So go ahead and balance it for me, Anaya. Victorian said it was 2523. We'll do the math. 2523. So 2 and 2. 10. No. 4, 7, what? 4, 7, 4, 6. Ends are balanced. H is 12 and 12. O's. Yep. So that's balanced. 4, 7, 4, 6 is balanced. So need to take what I know and put it over 1. What do I know, Logan? .7 moles of NH3 put over 1 times. Dang, what's going on the bottom of this next fraction? So 23.7 moles NH3? No. Mole NH3. Mole NH3. Yes, ma'am. And top mole H2O, because that's my unknown. That's what my question is about. Now, where do I get the? Darian says 27.3, 23.7 should go in front of NH3. That's incorrect. Where do I get that number that goes in front of these compounds? The coefficients, the balanced chemical equation. So I know I have 6 moles here and 4 moles of NH3. Balanced chemical equation, so moles cancel. So it'd be 23.7 times 6 from the balanced chemical equation. In front of H2O, I had a 6. Okay. In front of NH3, I had a 4. 35.6. That ain't right. Oh, okay, gotcha. Okay. So 35.55, and the calculator answer, you needed to round it to the even number, 35.6 mole. Mole what? HO, because that's what's not canceled out. I'm going to work one more out. That's probably as hard as they get. Yeah. The hardest thing of the day is probably honestly going to be balancing it. I mean, that's really probably the hardest thing. Oh, hopefully loud again. Y'all are best friends now? And you need to find better friends. There you go. This is hard. Nope. Go balanced. I want you to solve it out on your own, and then I'll work it out, okay? Solve it out on your own, then I'll work it out. Actually, hold up. I want to change this question. So give me a second. I'm going to pause this out and delete it. I want to change this question. Yeah, I think so. Tonight. All right, given the final balance equation, find, I don't, find each following, doesn't matter. Here's the question. How many moles of product is formed when 6.3 moles of oxygen is consumed? How many moles of product is formed when 6.3 moles of oxygen is consumed? So my known substance here is clearly oxygen, isn't it? That's what I know about. What is my unknown? I heard an answer. Water? Is that the only product? No. And carbon dioxide. So I have to do two problems, don't I? Because I need to know how many moles of water are formed and how many moles of carbon dioxide are formed. Because those are both my products. So you do the same thing, but with one with water and one with carbon dioxide. So 6.3 moles O2 over 1 times 7 mole O2. Once again, I got that 7 from right here. And then 4 mole CO2 is one problem. And my other problem is 6.3 mole. Then I asked about the products. So I had more than one problem to do. 6.3 mole O2. God, that's horrible writing. 6.3 mole O2 over 1 times the 7 mole O2 on the bottom does not change, does it? No. Only thing that changes is now 6 mole H2O. Moles O2 cancel. So what's the top answer? 4.6? 3.6? 3.6. 3.6 mole CO2. And the bottom, 5.4. So, what's my answer? What? No, that doesn't mean moles of products. So I have 3.6 O2 and 5.4 H2O. Add them together. Add them together. 9 is not the correct answer. 9.0. I'm adding and subtracting 9.0 moles. You have one homework problem like that, okay? Of products. You can say 9.0 moles or 9.0 moles of products, okay? Yeah, you can write moles of product or just moles. You only have one question like that today, and it's actually a multiple choice question, okay? So, your homework for that, make sure you input your answers into Google Forms. Make sure you show your work. It's wrong if there's no work, okay? It's wrong if there's no work. And this is just a Google form. I didn't print a worksheet out with it, okay? So it's going to stay in the same order. So that's my incentive to make sure you show your work. It'll be in the same order the whole time, okay? And I will post this video whenever. I don't know how many questions are there. There's 29 points. Some are worth 2 and some